A process contains sequential statements similar to those found in software programming languages. Which ones can we use to define the behavior of our model? Hello and welcome to this tutorial. In the last video, we used a simple process to implement an AND gate. However, usually we would not use a process for such kind of logic, since this can easily be implemented as concurrent logic, hence without using a process. Still, processes are very important but require few more statements to exploit their intended functionality. Let's start with the if statement. It is used to test for various conditions and works similarly to the if statement in programming languages such as C++ or Java. On the left, you can see the basic structure of it. Note the spelling of else if, which can be used to test another condition in case condition 1 is not true. It is also possible to define sequential statements in case all tested conditions are false using else statement. Finally, the if block always ends with the end if and a semicolon. Now let's have a look at a short example. The first line tests the two signals x and y. Both conditions are connected with an AND statement. Therefore, only if x is 5 and y is 9, the condition is true and a is assigned to z as defined in the second line of this example. Next, the condition x greater or equal 5 is tested. However, only statements after the first true condition are executed. So if the condition in line 1 is fulfilled, this condition is not tested anymore. If both conditions, the condition in line 1 and 3, are false, C is assigned to Z. There is one design pattern that we will often face when designing a digital circuit using VHDL. Synchronous processes are important to avoid timing issues, since these blocks are triggered at the same time by a global clock signal. If statements are usually used to implement such processes. Let's have a look at a simple example. A synchronous block only uses the clock inside the sensitivity list, so only events on this signal trigger the process execution. In the next step, we check for the rising edge of the clock. This means that we only want to execute sequential statements directly after the rising edge of the clock signal. Afterwards, in case a reset is requested, 0 is assigned to the output signal Q, otherwise the signal value of D is assigned to Q. Sometimes we want to test a signal on certain states and execute individual statements for each of them. This can be implemented using the if statement. However, this can also become a mess when many signal values have to be considered. In addition, the order of the condition sets the priority of each case. Therefore, VHDL provides another statement, the case statement. On the left, you can see the basic structure of it. Thereby, all possible choices must be included unless others keyword is used as the last choice. The choices always come with a when keyword in advance. After the arrow, we can then define the behavior of the model for each case based on sequential statements. Let's have a look at a simple example. On the left, you can see the case structure for the signal cell. The lines 2 and 3 thereby describe the behavior of the entity when cell equals 0, 1 and 1, 0. In the first case, A is assigned to Z. In the second case, B is assigned to Z. Finally, the The fourth line defines the behavior for all other signal values of cell. Okay, so let's sum it all up. Using if and case statements allows to implement more complex behavior in a model's architecture. With this in mind, you will be able to design a broad range of digital circuits for the applications you are working on.